Hey everybody, this is Mr. Beckstrom, and today I want to take a look at a sample problem from section 7.3. This is on estimating a population standard deviation. So this is number 13 on page 340, and it says, in a study of speed dating conducted at Columbia University, male subjects were asked to rate the attractiveness of their female dates, and a sample of the results is listed below. So 1, not very attractive; 10, extremely attractive. Construct a 95% confidence interval estimate of the standard deviation of the population from which the sample was obtained. So here it looks like they have 12 different values. So that means that 12 people were given a result of either not attractive, very attractive, or somewhat in between. Looks like somebody there was pretty good looking. We got a 2 in there, so somebody was not very impressed, but 12 total results. And we want to set up a confidence interval with 95% confidence level. So, and this is how we're going to set it up here. So what this is, that's the sigma symbol, which stands for the population standard deviation. So we want the population standard deviation to be between this value here and to be between this value right here. So let's kind of go over what this notation means, and we'll go about how we find it. So this is going to be the new distribution critical value here that we're going to need to talk a little bit about. This is the chi-square. So the x with the little 2 there, that's the chi-square. So this is the chi-square right, and this is the chi-square left critical value. So chi-square left critical value, chi-square right critical value. The lowercase s is the sample standard deviation, so that's squared for both sides. The n, as we know, is the sample size, so that's n minus 1. And everything else is good, so these are all numbers that we plug into both sides. So we should get that the standard deviation is between 2 values. Alright, so let's go ahead and see what we need to do in order to complete this interval. Well, n is going to be pretty easy, right? We just count up the number of values there, which is 12. So n is equal to 12. The sample standard deviation, well, we went over the long way of doing that, right? We could, what could we do? We could find the mean, add up all the values, and divide by 12, and then go through the whole table. But that's a lot of work when we can have our calculator do that for us. So by now, we need to know how to have our calculator find our sample standard deviation for us. So in order to do that, we just put it in. So we go to Stat, Edit. I already put it in my L1 list here. And in order to find that sample standard deviation, I go to Stat, Calculate, one variable stats. So enter. I'm going to pull it from my L1 list. I don't need to put anything in frequency. Calculate, and the S there is my sample standard deviation. I'll go ahead and go out 3 decimal places, so 2.216. So S is equal to 2.216. 2.216. All right. Got that. Now, all I really need left is my chi-square right and my chi-square left. So chi-square right, what is that value equal to? And my chi-square left. So here's where I need to know my table and how to look this up. So remember, well, we need to read the chapter to learn a little bit about the chi-square distribution, but it's this non-negative right skewed distribution that kind of looks like this, right? So it's right skewed, it's non-negative, so it starts here at 0 and it goes all positive values. This is a 95% confidence interval, so we're going to chop off the the left tail and the right tail, and the area in the middle here is 0.95. That leaves 0.05 left, so the area in both of the tails is going to be half of that, so 0.025 in each tail. So we're also going to have 0.025 there, 0.025. Now remember, like the t-distribution, the chi-square distribution is also based off of the size of the sample. So we're going to use what's called the degrees of freedom, just like we did with the t-distribution that we used just like we did when we were calculating the mean. All right, so now what we need to do is go ahead and use just a moment here. Let me pull up my table that I have, which should be coming up here in just a second. Where's my, oh, wrong table there. So now let's go down until we get to the chi-square table here. So there is the t-distribution, and here is my chi-square distribution. So remember, we had 12 values. We had 12 values, and that means our degrees of freedom is going to be one less than that, which is 11. So here's the row that we're going to use is 11. Now this says the area to the right of the critical value. So the area to the right of this critical value here is 0.025. 0.025. So we're going to look for 0.025, so that's right here. So 11 and 0.025 is going to be 21.920. So this is going to be 21.920. And then the area to the right of this critical value here is 0.950 plus 0.025. It's all of this area here. So that's going to be 0.975. So go back here and we're going to find 0.975, which is right here. With 11, that's going to be 3.816. 3.816. So this critical value is going to be 3.816. So this is our left side. So here's 3.816 there. And this is our right side, 21.920. And this is how we find our critical values. We take our confidence here, we write in decimal form in our main body. We take the remaining part of that, which adds up to 100, and we divide that in half and put it in our two tails. And then we use that table there. I think it's table A4. Table A4, which is the chi-square distribution. It says here area to the right of that critical value. So you look at the area to the right of it with the degrees of freedom, which remember is one less than your sample size, and you match that row with that column to find that critical value. All right, and then we're just going to put it in here. So let's go ahead and do that with our calculator. So we could do this all at once. So let's go ahead and do the right side first, since we have all of our values. All right, so the right side looks like the second square root, and I'm going to put the entire top here in parentheses. So this is going to be open parentheses. Now n minus 1, that's just going to be 12 minus 1, which is 11, times s squared, that's going to be 2.216 squared, like this, and then close parentheses. So this is the whole top in parentheses, and then divided by just this critical value here. It looks like it's squared, but that's not actually being squared. That's just part of the actual critical value notation. It's called chi-square. It's called, so this isn't actually being squared. That is an actual, just part of that notation there. So divided by the chi-square left, so 3.816. Divided by 3.816, and we're going to get 3.76. So over there we should get, so we're going to get 3.76. So 3.76 over there. And now let's do, that's going to be on this side. And for this side over here, let's do the same thing. So second square root. And we're going to do, once again, n minus 1 is just 11 times 2.216 squared, all right, and divided by, and that's just going to be the chi-square right, which is 21.920. Just like that, and that one's 1.57. So this is 1.57. All right. So tell us. What this says is that we can say with a 95% confidence that the true standard deviation lies somewhere between 1.57 and 3.76. So about 19 out of every 20 times that the actual population standard deviation, that the actual distance, average distance that the data falls from the mean is going to be around 1.57 and 3.76. All right, guys. So the one tricky thing with this section and the follow-up section in 8.4, when we do this same kind of hypothesis testing when we're doing it about standard deviation as well, is that our calculator does not have chi-square distribution kind of built into it. There is some programs that you can download, but the programs are finicky and don't work really well. I've tried to do that. So we don't have like a chi-square distribution program already built into the calculator, so we can't just go in there like we can and do like a t-interval or prop z int or something like that. So we really have to be able to use our tables and these formulas in order to do these intervals and later to do the hypothesis testing. So we have to know how to set these curves up and how to do all of this stuff. So I really wanted to make sure that I went through this entire process here. So if you have any questions, let me know. Please make sure you go through this video a couple of times and you get all of this down. All right, I hope you all have a great rest of your week. Thanks. Bye.